Hey there, educator, and welcome back to the Make Math Happen podcast. I'm your host, Lanisha, and as we step into January, I want to take a moment to connect where we've been with where we're going. In December, we kicked off season 4. We spent some time seeing math. We explored geometry as the visual foundation of mathematics, how students learn to notice structure, reason about space, and make sense of relationships before symbols ever appear. We talked about movement, measurement, similarity, and scale, and how those ideas prepare students to see mathematics as connected rather than fragmented. As I continued mapping this work forward, one thing became increasingly clear. Before students can meaningfully connect quantities through ratios and proportions, they need a strong understanding of what those quantities actually are. So before we move into connecting math with the ratios and proportions, January is going to be about understanding math. And by understanding math, I mean giving students time and space to make sense of quantities, no matter what domain those quantities show up in. So for January, for this month, we're focusing on the number system, not as a checklist of skills, but as a way for students to reason about value, distance, and relationships. This is the work that makes ratios feel intuitive later. This is the work that supports algebraic thinking instead of rushing past it. Think of this as the missing chapter that often gets skipped. Not because it isn't important, but because we feel pressure to keep moving. Understanding math isn't a detour, y'all. It's the foundation that allows everything else to stand. And with that in mind, let's get into it. When students struggle with operations involving fractions, decimals, or integers, we often say they're missing skills. But more often than not, what they're missing is the understanding. They're missing the connections. They're missing all of those nuanced ideas that you're processing in your mind without even realizing it. Rational numbers are not just numbers on a page. They represent quantities, relationships, and positions relative to one another. And students begin developing this understanding long before middle school, whether we honor that progression or not. In the earliest grades, students are learning what it means to count, to compare, and to represent quantities. They learn that numbers describe how much, how many, and eventually how far from zero. As students move through elementary school, they encounter whole numbers, fractions, and decimals using models, area models, length models, and number lines. These experiences matter, and they really set the stage. They teach students that numbers are not isolated symbols, but values that exist in relationship to one another. By the time students reach middle school, rational numbers should feel like an extension of what they've already experienced instead of something that is completely brand new. One of the most powerful tools for understanding rational numbers is the number line. The number line organizes value, direction, and distance all in one place. It allows students to see that negative numbers aren't mysterious, right? They're simply values in the opposite direction. It shows that fractions and decimals are not separate topics, but points along the same continuum. All we're doing is zooming in on that number line. When students understand the number line as a measurement model, they're better prepared to reason about magnitude, to reason about comparing values, and to make sense of operations later on. Too often, though, we introduce the operations on rational numbers before students fully understand what those numbers represent. And I get it. We are up against pacing. I understand. But I want you to think about this. We teach rules for adding integers before students can explain distance from zero. We teach fraction division tricks before students understand fractions as quantities. And then we wonder why the procedures don't stick. Understanding has to come first. Because when students don't understand what a number represents, they can't judge whether an answer makes sense. They have no internal reference point for value. They don't know if a result is reasonable or wildly off because they don't yet understand the relationships between the quantities in the situation. Students need time to reason about what a number represents, how numbers relate to one another, how value changes based on position and scale. Without that foundation, operations become fragile and they become disconnected. This is why students will confidently tell you that an answer is negative when the context clearly describes a gain, or that dividing a fraction makes a number smaller even when the situation demands the opposite. They're not being careless, they're guessing. They're guessing. And they're guessing because they don't have a sense of magnitude or direction yet. Reasonableness is not an extra step at the end of a problem. It's a habit that grows out of understanding. When students know that numbers live on a continuum, that distance matters, and that scale changes meaning, they can pause and ask, does this answer make sense? And that pause is powerful. It's the difference between executing a rule and reasoning through a situation. It's the difference between following steps and making decisions. When students can estimate, compare, and justify before and after computing, they begin to own the mathematics instead of relying on memory alone. That's the work of understanding math, and it's the work that makes every operation that follows more stable, more flexible, and more meaningful. I just recently watched a segment of a series that Dr. Pamela Harris did on developing mathematical reasoning. And she talked about the different parts of the brain that light up when you're doing something from memorization versus when you're doing something from reasoning. And it's such an interesting idea that I don't think that we pay enough attention to. So if you haven't checked out the amazing Dr. Pamela Harris, please check her out because all of her resources are amazing, spot on, insightful, inspiring. And I've been digging deep into those resources over the last year. And I am really behind, to be quite honest with you, because she's dropped a lot of books, a lot of resources. But yeah, there's no time like the present to get caught up, right? So anyway, this is where unfinished learning often shows up. Okay, so students are not behind because they are incapable. They're behind because making connections across ideas is cognitively demanding. I've been talking to you guys about the development of that prefrontal cortex. Students need help organizing and linking those ideas together. It is not something that they are prepared to do on their own. And if they're not prepared to do it in middle school, the age that I work with, then think about how ill prepared they are to do it in elementary school. So they really need us to be experts in the instruction and introducing those ideas and giving them those opportunities to make sense of those ideas through our guide, like through our guided facilitation. They need us, not for us to stand up there and lecture them. I don't mean that. But they definitely need us to be intentional with the task that we're using, with the sequence of the instruction, with the opportunity, the time that we're giving them, right, to grapple with things. So when instruction moves quickly, from one topic to the next without making relationships explicit, students are left to do that connecting, that linking on their own. And many of them can't. Teaching topics in isolation doesn't repair unfinished learning. Teaching topics in isolation deepens unfinished learning. And I'm going to pause to insert another idea from Dr. Pamela Harris. A lot of times people go to the procedures or some of the rote memorization because they feel like kids can't reason or they don't have time to let kids reason or because these kids are so behind. So I'm just going to focus on one strategy. I'm going to give that to them and then I'm going to let them practice that over and over again. One thing that I want to emphasize is students with unfinished learning or students with learning disabilities, and I'm not lumping them all into the same category, but I do want to give you something to think about. Their working memory is not as strong as a student that we would consider advanced, right? A student who might be in the gifted program, their memory is not as strong as those students in that gifted program. So the reasoning is actually going to be better for those students because they're not going to be able to remember all of these isolated topics that you're teaching, all of these isolated strategies, all of these isolated algorithms that you're teaching them. They're likely not going to remember them. And if they remember them, they're not going to remember when to use them or how to apply them. So teaching them to reason, teaching them to think about the size of numbers, teaching them to think about, does something make sense? Teaching them to think for themselves, which is something they really do have to practice, is going to serve them better and for longer periods of time than the algorithm that you are pushing on them because you think that it's going to be helpful. Understanding math means slowing down enough to let students locate numbers on a number line, to explain why one value is greater or smaller, to reason about distance instead of memorizing rules, connecting fractions, decimals, and integers as a part of the same system. The same system. When we're thinking about reaching those students who we feel have unfinished learning, it's not about remediation, it's about coherence. How are the things linked together? How are they connected? What makes sense about them? Okay. So even when the focus is on another domain, like expressions and equations, we can give students space to make sense of the numerical relationships before expecting them to formally represent those relationships. We're expecting students to create expressions and create equations and solve equations when the students have yet to truly understand the numbers that are involved, the quantities that are involved. Every day is an opportunity to strengthen one or more of the standards for mathematical practice, making sense, reasoning, modeling, attending to precision, looking for structure. Before we close, here's something that you can try immediately. Take one task you're already planning to use and pause before students compute anything. Ask them to locate the quantities on a number line, estimate where the answer should fall, or explain which value should be greater and why. No solving it, just sense making. This month, we'll continue to build that coherence. We'll explore how negative numbers connect to distance and value. We'll make sense of fractions through division and meaning instead of tricks. And we'll close the month by showing how strong number sense naturally transfers into ratios and algebraic thinking. When students understand quantities, connecting them becomes possible. And that's where we're headed next. As we move through this month of understanding math, I also want you to know that my Seeing Patterns Building Power series will be releasing on February the 1st. That work is designed to support exactly what we're talking about here, helping students notice structure, reason about quantities, and build power through patterns instead of memorization. Same story, y'all, and the next chapter is coming soon.